Okay, welcome to week 2 of the online elementary statistics webinar. This is a tough week, I should let you know, in terms of content. Not necessarily work to do, but content is pretty tough. We just have one chapter, but it's a tough chapter. A lot of people have trouble with it. So, be ready for that. Watching me do it is definitely not the same thing as being able to do it yourself. It's easy to watch, very hard to do. I like to think of it a lot like kickboxing. Very easy to watch someone kickbox. But try getting in a ring. Good luck. Trust me, I've done it. So we're gonna be doing probability, which again is the hard part about it for most people is that most of the problems look a lot like word problems in your prior math classes. And maybe I'm wrong, but my guess is most of you didn't love the word problems in your old math classes that you took. So just to note, that's what we're going to be doing. We're going to be doing a lot of word problem type things, as we'll see. But I'm going to try and make it relevant. I'm going to do my best. The other thing, so today we're going to go over chapter 3, which is probability. We're going to be looking at probability of an event, the probability of 2 events happening, the probability of either one or another happening, the probability of one if you know another one has already happened, all kinds of things with probability. We'll look at independent events and mutually exclusive events. And I'll actually start out with a little thing on combinations, and we'll use our calculator for that. I better pop up my calculator. And then after that, I'm going to be talking about Project 1. So take Project 1 very seriously because it's a lot of points. You have to do Project 1. You want to do it well so that that'll get you ahead on points in the class. So let me ask you, just to start out, do you have any questions at all about anything that I can answer?
I guess my question was, when I was doing the homework, you can hear me, right?
I can hear you.
Okay. So when I was doing the homework, and also when I took notes on your slides, I wrote down like all the equations manually, and I noticed that I was doing a lot of them manually. Is everything really done on the calculator and not, writing it down?
Just a bit. I think the only thing that the calculator doesn't do is a z-score.
Okay.
So
I think I had a little difficulty with that one because I had a little difficulty with that one on the homework. Like the example that you had in the PowerPoint, I tried to do it like that, but I think the verbiage was different, and then I had a little difficulty with that.
Yeah. Now for computing the z-score, it involves the standard deviation and the mean. The standard deviation and mean, let the calculator calculate those.
Yeah, that's what I realized.
But you do need to know how to subtract the value minus the mean, figure that out, and then divide by the standard deviation, or stick it in parentheses and divide by the standard deviation. So that's about it. Later, I think in another 2 or 3 weeks, there's going to be a few formulas you're going to have to use that the calculator doesn't do. But for the next 2 or 3 weeks, the calculator is going to do it. You definitely need to know how to use your calculator. And for the project, you're not allowed to do anything by hand. You must use the spreadsheet. That's an absolute requirement. And I'll talk about that in a bit. So hopefully that answers your question. Yeah, you definitely don't need to know just a zillion formulas. This class would be brutal and horrible. Now, for some of you, it may already be brutal and horrible, but it would be particularly horrible and brutal if I made you do all the calculations. When I did statistics, I had to do all the calculations by hand, but that's because I'm old. They didn't have computers that would do it for you. But for you guys, use technology. It's there. I've never met anyone in the real world who has to do statistics and doesn't use technology. It just doesn't make any sense. The hard part is to decide what to put into your calculator or the computer, based on what you are looking for. That's the hard part, not how to use the formulas. Any other questions? Again, I want to remind you, this is the best time to have questions because I can answer them right away instead of emailing or answering them in a post. Any other questions?
That's a good question.
Yeah.
The assignments, when I went to do them, were were really different than what I expected. They were a little far over from the videos and the webinar. So should we rely on the text to study to have success with the assignment?
You definitely should be reading the text.
Okay.
The text is not optional, it's required.
Okay.
So you definitely should read the text chapter. Okay. So the answer is you should watch the videos.
I'm sorry?
You should definitely watch the videos and read the text.
Yeah. As far as the problems go, they seem to really come from text more than.
Yeah,
that changes a little bit as the class goes.
Okay.
Okay, I definitely felt the same way.
Yeah.
I was like following along. I've taken notes on the webinar and then on the PowerPoints and everything, and then I did the homework, and then I felt I had to really search around a little bit more.
You got to read that the 2 chapters, but if it makes you feel good, we had 2 full chapters last week.
It definitely makes me feel good.
And that's the last time we're going to have 2 full chapters. We're going to have 2 partial chapters next week, and that'll be it for 2 chapters at all. But we're not even doing the whole chapters next week. So we did 2 full chapters, but there's nothing that is like really deep in those chapters. Whereas some of the other chapters that we're doing, there's a lot of stuff that's hard, including chapter 3, which we're doing today. Other questions? Okay, so I have a question for you. So what do you think the probability is, given that this is a week of probability, that I can start planning on buying that house on the Lake Tahoe with 6 acres that costs $40 million? Now, I need to show you something that will help you understand. Can you see? You see what that is?
Did you win?
I don't know. Hasn't happened yet. What's the probability that this is a winning ticket? So you may not be able to see, but there are 3 sets of numbers here. So when I went to the gas station store, I said, I want 3 tickets. So there's 3 sets of numbers here, and that actually matters for the probability. And what's the probability? Now, I don't expect you to be able to answer this in your head. But I do expect you to kind of follow through with what I'm going to be talking about, and then we'll get that probability. Any questions on that? Okay, so I'm going to share my desktop multiple times with different shares, as we'll see. And this is the first time I've actually done one of these. So let me find it. There it is. Okay, so you should all see, I like to use Paint because I can write and you can see what I'm writing. Let me do a couple things. Do that. And then just one more thing. I gotta move the chat over. I can't see it. Oh, I lost it. There it is. There. Now I can read chats if they happen. So the first thing, if this works, is we're looking at a probability. So one thing that shouldn't be a big surprise for any of you is we use the capital P for the word probability. Makes sense, right? So what you usually do is you write P and then parentheses, and then whatever the probability is that you're interested in. In this case is, I don't know, win. I want my ticket to be a win. Any questions on that so far? Okay, probability, whether you like it or not, is defined by a fraction. So whenever you're looking at probabilities, we're thinking about fractions. Any questions so far? The numerator of this fraction are going to be, corresponds to the number of ways of what I'm interested in occurring. So in particular, this is a very easy question. How many different ways can this be a winning ticket? And by the way, I need that $40 million house. I'm not talking about a little nothing win. It's all or nothing. I'm greedy. Got it? So I need to be the mega lottery winner. So how many ways are there for this to be a winning ticket? And only
3.
by, huh?
3.
3. Okay, I told you it was easy because I told you I bought 3 tickets. So the numerator is 3 because that's the number of ways that this ticket could be a winning ticket. Do y'all agree?
Mm-hmm.
Now we need to find out the denominator. And the denominator are the total number of things that could happen. Most of them are going to be losers, right?
50 million.
Okay. And this is going to be hard. So this is something we're going to have to do. The first thing, and let me ask you, you can put in the chat box if you want. For any of you know the rules of the Mega Lottery? Do any of you play the lottery? Nope. 50 million, not quite. It's a lot more complex than that, I promise. Any of you play the lottery? Okay. I only play the lottery 3 times a year, and that's because I use it in class. And I teach this in the fall, in the winter, and in the spring. Okay. So I think I need to show you how to play the lottery. So I need to go to a new share. That is, let me go find it. There we go. Okay, so you should be able to see that. And this is the Mega Millions, which is the one I bought. There's a few different games you can play in California. And, oh, by the way, a couple years ago, I wasn't even allowed to win the lottery. It'd be against the law. But now I can win. So I'm going to try. I'm hoping. Okay. So the first thing I should do is how to play, because we need to understand it. Okay. I don't need step 1. I already did that. I bought it. Step 2, pick 5 lucky numbers from 1 to 70 and 1 mega number from 1 to 25. The funny thing is that I've been doing this for a lot of years now. In fact, I played the first lottery in California. That was in 1984. And it changes more than once a year in terms of the rules. So most people don't even notice, but I notice. So we need to pick 5 lucky numbers from 1 to 70 and 1 number from 1 to 25. You got it? So how many different numbers from 1 to 70 are there? How many different sets of 5 unique numbers are there from 1 to 70? And that is not something any of you can do in your head. Okay, unless you're one of those really, really weird people. I'm one of those weird people and I can't do it. But instead of our head, what do you think we might be able to use to be able to come up with this answer?
Probability formula. And a
You
calculator.
need more than that.
Calculator.
Calculator, yeah. Yeah, there is no way in the world you're going to want to do this without a calculator. And we're going to have a formula too. And the calculator is going to move that formula through. Okay, so the first thing I want to mention, what we're looking at, another way of saying the same thing, at least for the 1 to 70, 5 numbers from 1 to 70, is how many combinations of 5 numbers are there from 1 to 70? Does that make sense? So fortunately, the calculator does that for us. So let's go ahead. And I told you there's going to be lots of shares on this one. Now I'm going to show my calculator. Okay. Oh, by the way, I should jot it down. And there were 1 through 25. I'm going to jot it down so I don't forget. On a piece of paper, 5 from 1 to 70 and 1 from 1 to 25. Any questions on that? Okay, so let me share my calculator now. Okay, and if you have your calculator, follow along. I'm going to calculate this denominator. So what I'm going to be doing on this one is I'm going to hit, I believe, and if I don't, I have to erase that, I'm sorry, but I think the first thing I do is I hit the number 5, because it's 5 numbers from 1 to 70. Then I hit math. Math must be important, right? It is math. Okay, and then PROB. Any guess what PROB stands for?
Probability.
Yeah, probability. The people in Texas, these Texas Instruments people, they actually did a pretty nice job on this calculator. Other than that delete button, I really like everything they did. Okay, then I hit the down arrow to get to number 3, which is NCR. C stands for combinations. So I told you how many combinations are there of 5 numbers if you're choosing from 70. I hit enter. And you'll see the 5 got stuck below the C on the left. And then now 70, because I'm choosing from 70. Any questions on this? Now your calculator might look a little different depending on when your calculator was produced. But it's always going to be math NCR. You're going to have the 5 math NCR 70 is what you're typing. It might look different, but that's what you're doing. Then I hit enter. Oh, sorry. It's 70 NCR 5. I always do it backwards. One more time. 70, and then math. If it's 0, you know something went wrong. NCR, and then 5. Head backwards. Okay, we're close. What have we ignored? What haven't we used yet in the Mega Millions?
The 25.
Yeah, we haven't used the 25. So notice that for each of these like 5 from the 70, we could pick a 1, and then we could pick a 2, and then we could pick a 3. So we're going to have 5 times of these 70 choose 5s. So we're going to multiply by 5. So if I go times 5 and hit enter, that is going to be my denominator. Okay, which is the big number, 60,515,070. Any questions on that?
Wait, what did you do to get that NS times 5?
I just hit times 5.
I just hit times 5, okay.
Yeah, that's the easiest way. You could type the whole number and then go times 5, but it's a lot easier to go times 5.
Why did you multiply by 5? Sorry.
Oh, I'm sorry. It's supposed to be 25. So let me go times 5. I'm like, that's not the right number because I know the answer. It's times 25. There were 25 numbers. Got the 2. Okay, it's 302,575,350 is the denominator. So I'm going to write that down because I certainly don't want to memorize that number. 302,575,350. Okay. And now I'm going to go back. And let's go ahead. And I can put that number in. So it's going to take a while because it's a big number. 302,575. 350. Okay, so do you think I should like go and talk to a realtor now? Get ready to buy this thing? What do you think? Should I have high hopes?
Probably not, really.
Yeah, I hope you all know that this is an absolute minuscule number. Okay, I'm probably not going to win the lottery, but who knows? Maybe I'll come back to you next week with a big old fat smile on my face. But I doubt it. Okay, so I have 3. So I have about, I could estimate this pretty easily because there's a 3 on the top and 3 on the bottom. There's about 1 in 100 million chances. Do you see that? So it's about 1 in 100 million chances of this ticket right here being a winning ticket. You probably don't want to steal it from me with those chances. Any questions at all on this? Okay, so this is an example. This is an example of using probability to understand kind of decision making. And what I like to do is I like to show you kind of real life stuff. Okay, to understand, you know, when someone wins a lottery, it is really unlikely. Okay, don't just think that you're going to get it, and start making decisions based on the fact you bought a ticket. Okay, you can make dreams, that's okay, but don't make decisions because it's a very small probability. And notice probabilities always have a numerator and a denominator. The numerator is the number of ways the event can happen that you want to have happen or you're looking at having happen. And the denominator are the total number of ways that anything can happen. And that's probability. Any questions on that?
Can you repeat the numerator and denominator one more time?
So again, the numerator are the number of ways of what you're interested in happening. So in this case, winning. There are 3 ways to win. And the denominator are all the different ways that anything can happen, including all the wins and all the losses. Does that make sense?
Mm-hmm.
Okay, very important. We're going to be using this throughout the whole quarter. Okay, I want to do one more example. Let me type this in. Okay, so I'm going to give this to you just a second. I got to do a reboot thingy. It always takes a moment. Okay, before I show it to you, what do you think the probability is that just in the last, say, 3 years, we've had the global temperatures that we've been having recently? Had it just been kind of random events every year? So that's the question. I'll explain it when we see what we've got. So let's do it. Okay, so over the last 3 years, you will notice these 3 years, 2015, 16, 17, 18 is not done yet, so we don't have data for that, are actually the highest 3 years since records were taken in 1880. So could that just be a random event? Maybe we're just getting kind of unluckily warm. Do you think that's true?
No.
So the way you do it, first thing, and this is really what statistics is all about, is you have an idea, and your idea is we have global warming. Does that make sense? And then you collect data, and then you see if that data demonstrates that had your idea been wrong, that it would be very unlikely for what you see in your data to happen. Have I lost you on that, or do you see how that works? So in particular, we think kind of, our side, that in terms of what we think, is that we're in a period of global warming, right? The other side says, no, these are just random events. Yeah, it might have been warm, but that happens, right? So then what we do is we compute the probability that in any 3 given years, those 3 years are going to be the highest mean temperature of global temperatures in the past. And this is since 1880, and this was 2017. So that is, 137 years. So in the past 137 years, what's the probability that the highest 3 are going to be last year, the year before, and the year before that? Do you see how that works? And if that probability is really low, then we say we have evidence that we were correct in our hypothesis.
So I'm guessing that we're basing that assumption on history, right? That on like modeling and saying, so far this, based on everything that's happened so far, this is what we would expect to happen. And now we have an anomaly.
And what would the probability be that these 3 years that we've been watching would be the highest 3 years in the 137 years. Do you see that? Just by random chance. And if that probability is really low, you say that it wasn't random, something happened. Do you see that? Big red flags, that they call raising a red flag. You've heard of that before, right? You raise a red flag if the probability is really low for it to happen. And what we say is we're going to have evidence for our hypothesis. So let us calculate that probability. Okay, by the way, that's what this class is all about, is to be able to calculate the probability, see the probability is low, and then say, yes, we have evidence. Or the probability is not that low and say, well, we don't have evidence. Do you see how that works? That's the purpose of probability. You're not going to necessarily see it much in this chapter, but I want to point that out because that's what we're doing in this entire course, not just this week. So let's calculate the probability that these 3 years are going to be the highest 3 years in 137 years. Okay? So the first thing is how many different ways are there of choosing 3 years from 137? How do we figure that out? That's that calculator function, 137C3. Do you see how that works? It's the same as the lottery problem. How many different ways are there of having the last 3 years being the hottest 3?
419,220.
Actually, I don't want to say, it's a lot easier than making it. If you're just looking at choosing the 3 years out of 3 is just one way, these 3 years. Do you see? So it's a lot easier than you're making it. Do you see that? It's just one, right? You only have 3 years to choose from. You have to choose 3 years. How many ways are there doing that? One. Choose those. Do you see that? Mm-hmm. So the numerator is going to be 1, and the denominator, might as well pop in my calculator. Oh, sorry, wrong one. One more time. Calculator, there it is. So we're going to be looking at the denominator being, again, we're going to go to 137. And then we're going to go to math, prob, NCR, enter 3. And then enter again. Okay? Not as big as a lottery problem, but still, would you, stake your house on having only a 1 and 419,220 chance of being right? Probably not. Okay, so that's a very, very low probability. That's the denominator. 1 was the numerator. So it's 1 out of 419,000 or so chances that it could have just been random chance. So when you hear about scientists agreeing that global warming is happening, this is why. Okay, this is why they agree with the data, because the probability that this just happened with random chance is so low that it's a lot easier to say it's not random chance. Does that make sense?
I think they also, I hope this isn't getting off track, but I think they linked it to carbon emissions when they started studying them in Hawaii and matched that up.
Right. Now, the carbon emissions is the reason behind it. The fact that it's happening is the statistics. Do you see how that works?
Yeah, yeah.
And the carbon emissions are really important. And if this were a chemistry class, I would definitely get into that. But I'm not going to. And my minor was in chemistry. So actually, I know that one. But I can't get into it because this isn't a chem class. But I can talk about probability all day long because this is a statistics class and probability is a main piece of statistics. Does that make sense?
Wouldn't you need a larger sample size, though, than just the years since
Look at the probability. Is that enough to raise a red flag? If you have a 1 in 419,220 chance of something happening and it happens, wouldn't you go, oh my God, something's weird? Do you see? So actually, this one you don't. This is one that you don't need a large sample size, but
Don't
you need a large
trends look,
sample size, and then it's even smaller. Actually, it's even smaller chance than winning the lottery. The reason I use this one as an example is the calculation's a little easier. So this is elementary statistics. We could do more advanced statistics, and you're going to see that the chance is even smaller than your calculator can even handle. So the global warming's happening. There's no question about it.
What can we use to like compare numbers to see if that's like a high probability or a low probability?
What's that?
I said, what, like, is there a way to compare, the numbers to see if that is a high probability or low probability?
So kind of like, what's that borderline of high versus low? Is that what you mean?
Yeah, like what would be high, what would be low?
Okay. So let me talk about it. Okay, so first thing in social science and news, I don't know, Haley, what your major is, but if it were psychology or, media or criminal justice or any of those, then the agreed upon standard is 5%, 0.05. Okay, 1 out of 20, by the way. This is a hell of a lot lower than 1 out of 20. Do y'all agree? Okay, in medicine, you need a lower probability often because you don't want to kill anyone.
Mm.
You often go like 1 out of 100 or 1 out of 1,000. Does that make sense?
Mm-hmm.
In business, you'll often do a 10% because you're willing to take more risks in business.
Okay.
So it depends on the field of study that you're studying. I believe in environmental science, they typically do 1%. I'm not 100% sure of that, so you may not want to quote me on that one. But the point is, it depends on the field of study.
Okay.
So it's a complicated answer. Okay, but 5% is kind of the agreed upon standard in the news. Whenever you read a news article, they use 5%. Okay, now let's do some more. Okay, so we've got this. I'm going to do some kind of simple stuff. Okay, but simple doesn't mean easy. It just means that we can do it. And I need you all to participate in your chat box. Do you all have ability to type things in your chat box? I hope you do, because I'm going to ask you survey questions. And let me stop the share. Let me start a new share. Let me get there. And let's go to Paint. Okay, so I'm just looking at what we've got here, and let's see, how many people do we have? We have 10. I'm going to include myself, just because we can get 10 people. 10 is a nice number, easy to deal with mathematically, right? Okay, so there's 10 of us. All right, let's do something simple. Let's find the probability that if we randomly select one of us, that person is either lives in Lake Tahoe or is female. Okay, so what I want you to do is put in the chat box your answer to do you live in Lake Tahoe and your answer, are you female? Okay, so you should have 2 letters. Y, or Y. You could go and no and male, that's fine, but the shorter is Y than, yes for live in Lake Tahoe or yes for being female. And let's write this out. And I want to show you how to do this. And everyone has to participate or we can't do this. We're not going to be able to figure it out. So let's go probability of T. I'm going to say T for Tahoe. Or F. F for female. Sound good? Okay, we know that this is going to be a fraction, because probabilities are always fractions. What's the denominator? That's supposed to be easy?
10.
10, because there's 10 people. And again, oh, by the way, I live in Lake Tahoe, and I'm not female. So I'm a yes, YN. Maybe, I think I could put in chat box 2Y. So YN. Okay. So now what we can do is, there's two ways of doing an OR problem. If it's a small number like this, we can just count. And to be Tahoe and female, you need to have YY. So now we go through, and I'm just going to read this. I see Haley. I see Susie. I see Cecilia are all YYs. So there were 3 of them, another 3 in the numerator. That's a total coincidence, by the way. And the probability is 3/10. You got middle across. So it changes as we go. So I don't know if I can erase that. If I can go Control Z. Yeah, there it is. That worked. Make that. Okay, there's another way of doing this, and this is an equality, and that is equal to the probability of T plus the probability of F. But the problem is, if you add those probabilities, we're going to add all the Tahoe people, and we're going to add that to all the female, and why is that not going to work?
That's going to be more than 10?
We're going to double. It's not necessarily more than 10, but we're going to double count.
Double, yeah.
So people who said yes and yes. Oh, do you know what? I just didn't do OR. That wasn't a 4. Sorry about that. I didn't count right. Anybody who's an OR should be a Y or a Y. So either Ys are fine. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, what do you know? 10. Everybody is either female or lives in Lake Tahoe. That's rare, actually. So we have no male out-of-towners. I did not expect that, by the way. So the problem is, if you count the Tahoe people plus the female people, you're double counting the people who are both. Does that make sense? So we need to subtract the probability of Tahoe and female. Any questions on that? And if everyone answered, we can take all the Tahoe people. Those are the people who answered yes to the first one. So that's, let's see, Haley, Milagros, Susie, Celia, me. Wait, I got Milagros twice. Let's see. That's why, because, yeah, Milagros, you answered twice. All right, makes it to 9. Take that one away, because we did have one male out-of-towner. That was Jay Tubbs. Okay, if we count the Tahoe people, now the Tahoe people are the yeses to the first question. So again, Haley, Milagros, Susie, Celia, me. That's 5. 5 over 10. That's the probability of being in Tahoe, half of us, plus the probability of female. Now we're going to add all the Ys to the second question. And that is Haley, Casey, CHDO, Susie, Bill, Eric, Celia. And that's it. So that's 7. If everyone answered correctly. Okay. And then we're supposed to minus the people who are both. And that was 3 of them. And it works. Any questions on that? So that's how you do an OR question. And notice while we did that, we have an and also. And means they both have to be true, or means at least one of them is true.
Wasn't there 4 that were both?
I was hoping 3 or somebody answered it. I think, no, because Millergrass answered twice. Wait. Oh, you know, I'm confused. I see a YY from Millergrass and a YF. I think I'm just going to leave it. That's what you call a non-sampling error. When you get data that just can't be right. So I'm going to call it 3 and just say that worked because it should have worked. Okay, it's always tough when I do samples from you guys. Okay, so that's an or question, and we have an and question. The other thing we can do is we can say probability of, let's say, M. All right, well, the easiest way of doing probability of M, if you already know the probability of female, is you can do 1 minus the probability of not M. M being male, by the way. And again, if we had 7/10 female, you do 1 minus that, and that's 3/10 male. And that's called the rule of complements. So when you're using that 1 minus the probability of it not happening, that's using the rule of complements. We're going to use that a lot in this class. It's very easy. Do you agree? Okay, so the last couple things I want to talk about with probability are a couple words. Okay, I think I need to get rid of all of this. And the first one is mutually exclusive. I know that's 2 words, but it's one idea. Actually, I can do it easier this way. Hopefully that'll work. Okay, so that's mutually exclusive. So the idea of mutually exclusive, if you have 2 events that are mutually exclusive, they can't both be true. So an example of that, let's suppose you were interested in, let's say event A is that you were born in America. And event B is you were born in China. Now, why are those mutually exclusive?
Because they both can't be right?
Yeah, you can't be born in America and China. It just doesn't make any sense, does it? So in terms of the way to write this with probabilities, because remember, this is the chapter on probability, is the probability of A and B is equal to 0. There's a 0 chance of both happening. So notice that if our event A was being living in Tahoe, and event B is being female, are those mutually exclusive?
No.
No. In particular, Haley knows for sure. Why not? How come?
Because I can answer yes to both.
Yeah, because because we have somebody that's both born in lives in Tahoe and female. So the probability is not 0. It's going to be, I think it was something like 3 or 4 out of 10. Do you see that? So which is not a 0. So that's easy. Do you agree that was easy?
Mm-hmm.
Okay, so now the next one. Let me give you the next big definition and the last one of the day. Again, I only do highlights because that's all I have time to do because we only have so much time for these webinars. So don't forget to read the chapter and to watch the long video of the chapter video and, and do the homework and post on the Q&A, do all that kind of stuff. Okay, so the next thing I want to talk about is what's called independent. Okay, so kind of the idea of independence is that two events are independent means that if you know one of them happened, it doesn't change the probability of the other happening. Does that make sense? Okay, so for example, if event A is the London high school soccer team won today, and event B is you were able to attend the webinar. But do you think those are independent?
Mm-hmm.
Yeah, my guess is who won the soccer game in London has absolutely nothing to do with were you able to come and log into the webinar. Do you agree? So those are kind of the idea of independence. Whereas if you look at, say, let's say event A is that you are a registered Democrat, and event B is that you approve of President Trump's job that he's been doing. Do you think those are independent? Okay, those are definitely dependent. Okay, Democrats are more likely to disapprove of the job that Trump's been doing than non-Democrats. Do you agree?
Mm-hmm.
I tried to pick something really obvious.
I think more likely, but not written in stone.
Oh, no, it's not about written in stone.
Okay.
But you're given some information that changes the probability.
Okay.
Do you see?
Thank you.
Doesn't mean you should know for sure what's going to happen, but it's more likely to happen or less likely to happen now that you know the information.
Gotcha. It's not black and white. It's leaning this way or leaning that way.
Right.
Okay, thank you.
Okay, so let me write down again. There's math, the mathematical equations. It turns out there's 3 of them. So the first one is the probability of A and B, so both occurring, is equal to the probability of A times the probability of B. The second is the probability of A, and I'm going to put a little line segment. That means given the information that B happened. So the probability of A occurring given the information that B occurred is equal to the probability of A. In other words, having the information or not having the information doesn't change the probability. And then the third is the probability of B given the information of A is equal to the probability of B. In other words, it doesn't matter which one you call A and which one you call B. And that's what it means to be independent. If one of these works, all 3 of them work. If one of them doesn't work, none of them work. Got it? So if you want to test for independence, what you need to do is find the one that looks easiest and try to do that one. Any questions on that? Okay, so let me give you an example. Where is it? I have it, there it is. These guys. So hopefully you're all familiar with what you're looking at right now, are you? Okay, so I'm going to roll 2 dice. Just like that. And I'm going to look at 2 events. So let's say A is the sum is 7. And B is the first is a 2. Are these independent? And the answer is, without doing the math, you won't know. If I told you that the sum of these 2 die is a 7, does that make it more likely or less likely, or the same likelihood that the first was a 2? Does that make sense? But I could choose instead, if I tell you the first is a 2, does that make it more likely or less likely that the sum is a 7? Right? Because you can go either direction, because that's what the second and the third are. Or I can say, if you look at the probability of having a 2 and the sum being a 7, is that equal to the probability that the first is a 2 times the probability that the sum is a 7? So I have 3 choices on calculations. Which do you think is easiest? And again, you may not know because you may not play dice like I do. But it turns out probability of B given A equals probability B. Checking for that one is the easier of the two. I'm sorry, probability A given B equals probability of A is the easier. So let's look at probability of A given B. Let's find out what the probability of A given B is. So first, in words, what that means is that I tell you, B, I tell you that that's the first die roll. Do you see that? That's given. Given means I just told you. So now, what's the probability that the sum of the 2 dice is a 7? So if the first is a 2, how many ways are there of having a 7?
1.
There's only one way. What must the second be?
5.
5. Is that clear? It's the only way you're going to get a 7 if the first is a 2. So that's the numerator. If I tell you the first is a 2, how many different ways are there for outcomes to occur if all I told you the first is a 2? What do you think?
Say it one more time.
How many different outcomes are there for the sum if I told you the first is a 2?
1.
Okay, well, we could have for example, a 2 and a 1, that gives you 3.
6.
We could have a 2 and a 2, that gives you 4. I already got more than 1.
No, there's only one way, right? It has to be a 5.
No, that was for the numerator. So how many different things could happen?
6.
6, because it could be any of the 6 die roll for the second roll. Do you see that? 1 over 6. Any questions on that? Okay, now let's find out what the probability of A is. So how many ways are there of getting a 7 for the sum? So let's count them out. You can get a 1 and a 6. Do you agree? What else could you get?
4 and a 3 and a 5 and 2. So
Yeah, I think it's easier to go in order though. 1 and a 6. You could get a 2 and a 5. You can get a 3 and a 4. So let's see if you can count how many different ways are there of getting a 7.
Would you consider it like backwards too? You know, like 3 and 4?
Yeah, 1 and a 6 and a 6 and a 1 are different.
Okay, yeah.
So how many different ways of getting a 7?
6.
6. 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. That's 6 ways. You seen that? How many different die rolls are there with 2 dice?
36.
36, because, for example, for the 1, there's 6 die rolls. For the 2, there's 6 more. So it's 6 times 6. So that's 36. So, are they independent?
No. Or, wait. One affects,
Give me one more guess.
yeah, one affects the other, yeah.
Yeah, reduce the fraction, right?
Mhm.
6 over 36 really does reduce to 1/6. So these are independent. Okay. Had they been different, for example, had I said the sum was a 4, you'd find out that they were dependent because you get different numbers. Any questions on that? Okay, so that is the idea of independence. So again, I only give you kind of one example of each, but there's a lot of other examples as you watch through other videos and read the chapter, etc. And you'll get other examples. Any questions at all on this? Okay, so now let's get to what I call part 2 of this webinar. I need some water. And now I'm going to go to sharing. Yeah. Okay, so if we go to our syllabus, you will see Project 1. I know it's a while from now, but don't procrastinate this one. Project 1 is due October 21st. Okay, so you have, I don't know, 3 weeks or so. Okay, a little less, something like that. 3 weeks and a couple days. October 21st, I should say 22nd. I believe. Should be Sunday. I always have things due Sunday, and I just noticed on the calendar 21st is a Saturday. So I'm gonna have to check that, unless it's the 14th, but I don't think so. I think it's the 21st. Okay, let me double check before I mention it. Sorry if there was a typo. I might have misread my calendar. For
Sunday.
October 21st. I hope you say 21st. I missed on all these. Yeah, it should be 22nd. Sorry about that. So it's October 22nd. Let me fix that now. I'll have to fix the other dates too. I just noticed it. So October 22nd, which is a Sunday.
October 21st is a Sunday.
Is it?
Yeah.
October. Not my calendar. That's weird. Maybe my calendar's wrong. Okay, I have to check. Okay, well, I'll fix it later, but it's a Sunday of that week. Yeah, October 21st is Saturday, according to my calendar. I'm going to go fix it.
Hold on one sec.
Yeah, it's a Saturday. So it's actually not due October 21st, it's due October 22nd. Is when the project is due. So I'm going to go to click on Project 1. And this is the requirements for Project 1. All right, so think of a quantitative. Hopefully you guys know what the word quantitative means. What's that mean?
Numerical.
Numerical. Okay. So a quantitative investigation that someone might contract out to have done. Okay. So think about what someone might be interested in kind of learning about, and that is a quantitative investigation. And that's your project. Then go and perform this investigation and produce a report on it as though you were handing the report to the person paying for your services. Okay, so that's kind of the way you write your paper. Does that make sense? The purpose of the report is to make recommendations based on your findings. So be sure to make the recommendations throughout the paper. The purpose is not just to define statistics. It's to actually go to the next step and say, how do I use these statistics so that decisions that are good decisions can be made after having seen the statistics? Whereas had you not seen those statistics, you would not have been able to make those decisions. Does that make sense? Okay, include a statement on who has hired you and why. And by the way, you don't really have to have someone hire you. So that could be fiction, but there better be someone who might hire you. Do you see that? For a good price. Someone who's interested. Okay, any questions so far? Okay, below are the items that the report must contain. So you must do a sample. Okay, you're gonna have to do a survey. You're gonna have to ask people. So the survey has to ask people something. So things you're gonna have to identify in order to even talk about this is, what is your population? Your population could be, for example, all California community college students. It could be all people who live in South Lake Tahoe. It could be all people who live in California, okay? More likely than all people who live in California, be all adults. So I wanna warn you, I don't think it says it here, but a warning, don't survey children. Do you know what the problem is serving children? Anyone know the problem with it?
The parents get mad? Or their answers are
and if the parents get mad, it's not just about mad. You could get arrested.
Yeah.
Do you want to get arrested?
No.
Yeah, you don't want to get arrested. So that's why I'm telling you. But I'll let you know, if they're a college student and they're under 18, then they are considered an adult even if they're under 18. Their parents have actually signed away all their rights. I don't know if you realize that, but that's true. I don't know if any of you are under 18, but if which I'm not going to do, but if I had some kind of porn that I played to show you some statistics, then you're under 18 and I can still make you watch the porn. Does that make sense? I'm not going to do that, by the way, but it would be legal. But if you're not a college student, then under 18 is definitely not okay. Got it? So make sure in your population, if it's not college students, then it's got to be adults. You got it? Okay, the only way to ask children is to get express written permission and go through an ethics panel, which you were not going to do. Okay, so you should identify the population, and then you should decide on a sampling technique. You must either use simple random sampling, stratified sampling, or cluster sampling. You will notice that I have stratified sampling and cluster sampling linked. The reason is it's almost impossible to use simple random sampling. So if you think you're going to use simple random sampling, you better run it by me, and I'm probably going to tell you that's not simple random sampling. Got it? So good luck. In my 22 years of doing this, I had one student do it properly. And that was it. Everyone else who thinks they're doing it isn't doing it right. So you must use stratified sampling or cluster sampling, and probably not simple random sampling. You cannot use convenient sampling. You cannot use systematic sampling. Okay? Okay, discuss any bias that might have occurred due to your sampling technique. Note that the bias involves a misrepresentation of the population, so that the sample data will not represent the population data. Okay? Any findings of potential bias should provide a convincing argument why you think your sample is more likely to be higher or lower than the population mean. Got it? Because that's what bias is all about. So this is very similar to the discussion posts that was due on Sunday, except you're going to do a whole lot more explanation than just one paragraph. Any questions so far? Okay, so you're going to have to describe in detail how you're doing your sampling. Okay, again, the variable must be quantitative. The sample size must be greater than 30. 31 is fine. I wouldn't do a sample size of 3,000 because it would waste your time. It takes too long. But it has to be greater than 30. So if there's 3 of you in your group and you each survey 11 people using one of the good sampling techniques, that's good, you got 33. And that's not too hard, is it, to ask 11 people? Okay. Be careful about the word random. Okay, that's going to raise a red flag. I'm going to read it. And if you haven't fully explained what you mean by and how you actually randomly sample, then you're going to lose points, and good luck randomly sampling. It's almost pretty much impossible. So beware, just let you know. Just let you know what I've done is like every quarter I add more to this because I'm like, oh no, they shouldn't have done this. So then I put something in here to maybe help you guys understand not to do something. Does that make sense? Okay. Any questions so far? You must include all relevant charts. You must include a histogram. You must include a stem and leaf. You must include a box and whiskers. And you may include others. So you will definitely lose points if you don't have a histogram, a stem and leaf, and a box and whiskers. Okay, because you're going to have a stem and leaf, it's going to be much better if your survey question, if the answers tend to be 2 digits. Okay, or at least 2 digits. Otherwise, stem and leaf won't be very relevant. Okay, so make sure you have a nice variety of answers. So don't ask something like, how many times have you been to Africa? Because what do you think you're going to get?
Zeros.
0 from almost everyone, and you're not going to have a very interesting project. Does that make sense? Okay, so instead you could ask, say, and you don't have to ask this one, but something like, how many miles did you drive last week? Because you're not going to get too many 1-digit numbers. Does that make sense? You might get a few, but you're going to have a big spread of numbers, and it's better to have a nice variety than for everyone to be saying the same 2 numbers. Does that make sense? Okay. To let you know, you must use a spreadsheet, and I've said this a few times for this project. If we go to spreadsheet resources, I hope this does it, then my recommendation is Google Sheets, because I wrote it. There are other things you can use, but this is made for this project. So I have videos on everything that you could do, especially this one variable statistics, because that's what you're going to be doing. Just a note, if you click that, that sends you to Google Sheets. You're only going to have 1 column, by the way. You're going to have 1 column of data. If you say stratified by gender, you're not going to have a column of men and women. The stratifying by gender is just to make sure that you don't have a bias of one gender or the other. Your sample is still, your study is still about people. It's not a comparison study. You got it? I'm saying that because it's a big problem. A lot of people make that mistake. So you just type in your numbers. I don't know, 8, 22, whatever your numbers might have been. You don't have to do anything. There it is. You got it? Something you must include in your paper is this. It's really easy. You highlight it, you hit the right button, you hit copy, you paste it into your document. Most people, you could use a Word document, but since you're working together, it's a little easier to use Google Docs. Okay, but you don't have to. But whatever you use, you can copy and paste it into any document. And you must, by the way, because that's your proof that you used a spreadsheet. And if you use a different spreadsheet program, that's fine too. But it's really easy to copy and paste in, and you must do that. Does that make sense? Okay, the histogram will show up. The others may or may not show up if you go to stats. You go to box plot or stem and leaf. And I don't know, box plot. I need my permission to run. Yeah. And the app isn't verified. So it might not let it happen. So I want to show you what happens if it doesn't happen, because there's all kinds of security issues nowadays. By the way, I would never write a program that gives you a virus, but Google's scared. So you can always click on these links, and these links do the stem and leaf and box plot for you. And you can copy your data set in, and it'll give you one. Does that make sense? And that'll give you a box plot. You can copy and paste that box plot into your paper. Used to work great, and then Google changed. Sorry about that. One of these days, maybe I'll figure out, but I haven't figured out how to make it right. Any questions on that so far? Okay, so it must be there. So let's go back to project requirements. Okay, you must have an interpretation of each of the charts in the context of the study. So you can have a whole paragraph on the histogram, a whole paragraph on the stem and leaf, a whole paragraph on the box and whiskers. Don't just define what it is. Discuss what each chart says and does not say. Talk about how your client will use that information to make a decision. Does that make sense? If no decisions can be made from your project, you have a bad project. Okay, that means it wasn't interesting. So make sure you have a project where decisions can be made. You should also have a paragraph or two on comparing and contrasting the charts. Does that make sense? Talk about what they must, what information one gives that the other doesn't give. Does that make sense? Who might be able to read it and who might not be able to read it. You should give me a list of summary statistics and interpretations of each. So let me go back to the spreadsheet. So summary statistics: minimum, mean, sample variance. Sorry, not sample variance. That one's not important. Minimum, mean, sample standard deviation, median, maximum, Q3, N, Q1. Those are the main summary statistics so far. There's some others too. Z-score. Do you see where it says change this? If you do a Z-score with X being 120, you didn't change that number. Okay? You should do a Z-score for an X value that makes sense for your data. So for example, my minimum was 3. If I do a Z-score for 3, and I get negative 0.86, I notice we don't have an outlier on the low side, because negative 0.8 is not an outlier. Outliers are farther than 2 away from 0. So negative 2.5 would be an outlier. An extreme outlier would be like negative 3.5, farther than 3 away from 0. Okay, so don't use 3, by the way, because that's this data, and your data will be different. Does that make sense? So explore, do a different Z-score. Try the maximum. The maximum was 22. So the maximum was 22. Hit enter, and there's our Z-score. Aha, look at that. We have an outlier. So notice that 22 is an outlier. Does that make sense? You could check the next highest, which was 9. That has a small Z-score, so that tells you 22 is the only outlier in this data set. And then you can talk about it and how you're going to use that. When you look at outliers, is the outlier something that is a mistake? Maybe you mistyped the data or someone just said it wrong? Or is it something that's important and crucial and interesting? Okay? Maybe the person has a really long commute and they're driving 600 miles a week, okay, or last week because of some reason. And that's something you might be interested in. They didn't make a mistake. They really did drive a long way. Does that make sense? And you could use that for one reason or another. Okay? If you're doing something like how many hours of sleep did you get last night, then you might want to pick 8 for your Z-score. You might want to pick 8 also, because that's your standard amount of sleep that people recommend. Do you see that? So your particular data is going to have important numbers. And you're going to use that to find the Z-score. Any questions on that? Okay. None of this other stuff is going to matter. IQR does. IQR is the difference between Q3 and Q1. The mode matters. Sum does not. Sum of squares does not. Skewness does not. And kurtosis does not, because we haven't learned that yet. And we never will, by the way, in this class. Someday, maybe you'll learn it if you take some advanced statistics class, but we're not doing it. Okay. You could talk about percentiles if you're interested. Standard error, we will learn that, but not for a few more weeks. So don't put that in your project. That's post-project stuff. That's going to be really important on project 2, by the way. Any questions on that? Okay, so again, I set this up so it has everything. The reason it has more than what you want is that people have requested, I really want to know the kurtosis. Can you put that in? So I did. I figured I could add more stuff in. You just have to know not to read that. Is that okay? Okay. Let me go through more. All right. So pay special attention to the standard deviation. Okay, that's the main statistic for this whole project. Okay. Projects without at least a full paragraph devoted to the standard deviation cannot receive an A grade. Okay. And by the way, I'm not talking about a 1-sentence paragraph. Full paragraph on the standard deviation. So what it is, how to interpret it, how is your client going to make a decision after seeing the standard deviation? Think about it. Okay. What is the empirical rule? Okay. What does the empirical rule say about your data? Okay. And can you even use the empirical rule? So remember, that's by looking at your histogram and seeing if you have a normal distribution. But if you can't use the empirical rule, then you should talk about Chebyshev's theorem. Again, that was in the chapter 2, I believe. Okay. Any questions on all of this so far? Okay, you should also, I should just let you know that this is a paper. So it should be in standard paper form. It shouldn't look like you're texting a friend. It should have an introduction. It should have a body, and it should have a conclusion, just like any paper does. You should make sure, this is where I actually do care about grammar, and I care about spelling and all that. You can always go and have someone proofread it, okay, and check for that kind of stuff. Okay, so you should give me a synopsis of the importance of your finding, and include recommendations, okay, that will give to interesting parties based on the mean, standard deviation, IQR, et cetera, et cetera. In the recommendations include the values. So just to let you know, one of the things that I do when I read your paper, especially reading your conclusion, if the conclusion could have been written before you even looked at your data, it's a poor conclusion. Because the conclusion should be about what your data has revealed. Okay? So that's really important, just a note on that. Okay, so for example, if your study was on the age that students first learned the quadratic formula, and the mean was 15.3, don't just say the mean could be used to understand when people learn the quadratic formula. That you could have said before you even knew it was 15.3. You see that? Instead, you could write, students are learning the quadratic formula on average just after they turn 15 years old. Based on this, high schools should be leery about moving chemistry, which requires this knowledge, to the freshman year. So do you see that this statement could not have been said before you knew about the number 15.3? Does that make sense to you guys? So that's how you use your values. Okay? And all of these ways of using the values should be incorporated throughout the paper, not just at the beginning and the conclusion. Okay? Every paragraph should talk about what decisions will be made after reading whatever you're talking about. Do you see that? You should also talk about how further studies could be done in order to delve deeper into the topic. Okay, what else might you ask? Okay, also, how could you better your study to eliminate some of the bias that happened because of your sampling technique? Okay, you don't have to have a sampling technique that has no bias. And in fact, if you think you do, you're wrong. If you think you have no bias, you're wrong. There's always bias in a study. So you're going to do your best, or you're going to do somewhat your best to have an unbiased study. You're going to have bias, but then I want you to write about, if you had an unlimited amount of resources, how would you not have bias? Does that make sense? How could you do a sample that doesn't have bias? Any questions on this? Just to note, I'm not going to read all of this to you, but I also have a link. These are some things that were feedback from people who sent me their project draft, and I give them suggestions. I recommend you read this so you don't make the same mistakes. Okay, I'm not going to read it to you right now. All right, so let me tell you, and I'll let you read through like the font and things like that. By the way, don't use the word I, don't use the word me or we or us. That's not a professional paper. Professional papers are not about you, it's about the study. Okay, you are professional researchers. Refer to yourselves as the researchers, not we. Does that make sense? So that's just a note in terms of style of the paper. It's not about you, it's about the study. All right, so I want to go back to this guy because I want to type out a list. It's important enough that I really want to write it out. By the way, this is a bit of a longer webinar than usual because I'm going through the project. And there's a lot to talk about. This is chapter 3 and the project. So hopefully you're catching this on. And this will be recorded. So you could take notes is good, but you can also rewatch it if you want. Okay, so what should the steps you should do in the project? You should all know the very first step, which many of you have already done. What's the first step?
Finding a group?
Yeah, get your partners. If you don't have partners by now, you should be worried a lot. 3 is better than 2. If you have 2, you should post on the discussion forum, project discussion forum, I need another partner. Does that make sense? If you're alone, you should be posting on the discussion forum, please, please, you know, I need a partner. And you should look at everyone else's and you should reply to them. Can I be your partner? People are going to say, I already have 3, sorry. Or I have 2, yes, you can be the partner. If there's only 2 of you and someone asks you to be a partner, please say yes. Got it? Okay, so get a partner. 2. All right, decide on what you're going to survey, what your project is about. And that should be not you as an individual, but you in your partnership. You need to be in agreement. Okay, 1 project per partnership, and you only turn in 1 paper. Okay, step 3, post your ideas. And those are survey question, population, client, sampling technique. On the discussion forum. Okay, don't wait till the last minute to do that because that's just your ideas. And what I'll do is I'll read through that and then I'll give you feedback and I'll say, you know, your survey is a really good idea, but if you word your question in this way, you'll get responses that are a lot better in terms of people understanding what to say. Okay, or whatever I might say, but I'm gonna make suggestions for you. Any questions on that? Step 4. Step 4 is sample. So go out and ask the people, okay, after I've actually said, yes, the project's gonna be good. Okay, and you've fixed it. Step 5, write your draft. Okay, and of course you got to put it into the spreadsheet too. That's all part of writing the draft. Okay. Step 6, email me your draft. Okay, it's a big class, okay? We have a lot of people in this class, so the earlier you email me, the better chance you have that I'm going to be able to get it back to you so that you can actually read about it. Okay. If it's not 2 days ahead, so if it's not by Friday, it's not going to. Okay. I won't even look at it. Got it? So you need to have it at least 2 days before the due date, email to me, but better is like 4 or 5 days before so that I have enough time to look at it and then you have enough time to make adjustments. Does that make sense? What I will do is I will give you feedback. If it's one of those projects that needs a whole lot of work, I'm going to give you like the top 10 things you need to fix so that you can pass. Does that make sense? If it's a project that's like already a B+ paper, I'll still give you the top 10, but for you get an A. So the point is I may not give you feedback on every little thing you can do to get every single point to get 100%, especially if your paper needs a lot of work. Does that make sense? Because I'm not going to give you 30 pages of feedback. Okay, but I usually give you around 10 or so, 10 items to make better. Okay, and step 7. And since I'm running out of room, I'm going to write 2 things. Write your final draft, your final copy, or version, I guess is better, and turn it in. Okay, I would not wait till 11:50 p.m. on Sunday to do that, because you know how technology happens, right? Okay, I would have at least 24 hours in advance as your kind of committed deadline, so that if something goes wrong, you got a little extra buffer. That's a good life lesson, by the way, is to, when something's really important, give yourself a little extra time. Okay, and this is really important for this class compared to, say, just a discussion post or an assignment for chapter 3 or something. Okay, this is crucial for your grade. Any questions at all on kind of this list of things to do? So get your partners. That should be done already, or you should be panicked at this point. Decide on what your project is about. I would recommend having that done maybe by next Monday. Doesn't take that long. Post your ideas sometime next week. Pop them in the project discussion forum. That's where you post them, by the way. Not the Q&A, but the project 1 discussion forum. That you would probably do sometime next week. Okay, and I'm pretty good about getting back. I'll within 24 hours, I'll get back to you on it. Sample shouldn't take you more than a few days to do the sampling. Okay, sampling tends to happen at the college. And if you're from multiple colleges, then you have multiple colleges that you sample at. It's even better. Sometimes they happen at your work. If you're going to sample at a college and you're going to go to a classroom, get the professor's permission first, just to be cool. Okay, they almost always say yes, but you should always ask. Does that make sense? And I recommend making a copy of the survey for each student and hand it to them. They write it down. That way it's done in like a minute. You have the whole class doing it if you're doing, say, cluster sampling. If it's in your place of employment, get your manager's or the owner's permission first, unless you are the owner, and then you don't need permission. I don't want you losing your job over this project. Got it? If you're doing it, say, in front of Safeway, okay, make sure you talk to the manager at Safeway first. Does that make sense? So there's different places you can do a survey. If you say you're a college student if you're doing general public, and you say you're a college student and I have a statistics paper and I have to do this, then almost everyone will answer your survey. If you just approach them, say, will you answer a survey? Most people will just walk by. I'm just giving you some advice on how to kind of get this working. Okay? And if you wear a college t-shirt, you're even more likely to have them answer your survey because then they'll believe you. Okay. Writing your draft, again, that's gonna take some time. It's a lot of pages, usually around 8 to 10 pages, including posting the spreadsheet and the charts and all that. So it's usually like probably 5 or 6 pages of writing. Okay, I don't give a limit on writing, but If you try and do it in a page, it's not going to be good for you. So email the draft again. I would shoot for probably Tuesday or Wednesday-ish of the week before it's due. So it's due on Sunday, submit it by Tuesday. I'll get back to you probably by Thursday, and then you'll have a few days to work it out. Okay? And then again, I recommend Saturday to be your deadline. Earlier is fine too, but you're absolutely, you really want to focus on trying to get it done by Saturday so that you have that extra time. Okay, so it's 7:30 right now, and this is about as long as a webinar I'll ever get, but I did want to get through the project. I've done this in 2 webinars, but I thought we could do this in 1, and I just made it. So 90 minutes exactly. So as always, at the end of the webinar, you are welcome and encouraged to ask any questions you might have about anything. And hopefully I'm like a super millionaire by the end of the night or tomorrow. I forget what happens. Any questions about anything?
Well, it sounds like when we go to pick our topic and what it's about, that the group that I formed with, we were interested in doing, not surprisingly, a natural resource type project, but this sounds like it's human social science focused.
Well, you could do an opinion about natural resources.
Okay.
Do you see that?
Yeah. But we can't do, and maybe this will work for the second project, I don't know, we can't go collecting data on trees or water quality.
That's project 2.
Got it. Okay.
That's project 2.
Okay.
But project 1 has, because the whole point of project 1, or not the whole point, but one of the main points is to learn how hard it is to survey.
Okay.
And that bias happens, and to identify that and understand that.
Okay.
That's a big piece of the project. So that's why I make you ask people.
Okay.
Whereas you're not going to see that whole issue of bias and stuff if you're measuring trees.
Right.
Right? There's not a lot of bias.
They're more honest.
Yeah, they tend to be pretty honest. So that's the reason. It's not because I'm being mean. It's because there's some learning to be done in understanding the bias of gathering people's opinion or people's data. Okay, but you could do something on natural resources with people. How much resources are they using? Does that make sense?
Yeah. There's a lot we can pick from.
Yeah.
People.
Yeah. And there's definitely natural resource people surveys.
Okay. Thank you.
Okay. Other questions? Oh, you know what I forgot to do? You should all know. So, by the way, you should always remind me if I forget.
Magic word.
Yeah, which I call a secret, but that's okay. Ooh, that's too small. Make it bigger. That's still too small. 28's good. The secret word of today is given. Because remember, you have probability of A given B. That's how you read that. That's that little vertical line segmenty thing. So the secret word of today is given. Okay, of this week, actually. Any other questions about the project or anything else?
If we see you around the college, are we able to just go talk to you and ask questions at that time, or do you prefer your office hours?
Oh, no, you can see me. The only thing you can't do is if you see me teaching in a classroom, let me teach.
Okay, yeah, of course.
So if I'm in, and that's E106, that's the only classroom I'm teaching in, actually. Oh, I should mention one more thing that I forgot to mention, is on Friday, my office mate's going to prison, so I have to sub for him. He teaches in the prison program. So he's going to teach at the prison. So I'm going to be subbing, so I'm not going to be in my office at 10 o'clock. But I will be there after my third class. I'll be a little tired because I'll have taught 6 hours without a break and without lunch probably too. But I will be around my office at around 3 o'clock on Friday, this Friday. So there's a bunch of Fridays I'm subbing for my office mate. So sorry about that, but that happens. Usually it's not too big a deal for online students. So. because you usually can't make my office hours anyway. But yeah, you're welcome. If you see me on campus, just ask. If I'm running or something, I may say don't have time. But if I'm sitting in my office, come ask me. Come ask me. I'm in my office a lot. I'm around a lot, and I'm definitely here to help you out. Questions? Other questions? I want to remind you, if you have no questions, you could say goodnight, which I know Susie has and Eric has, but I'm also happy to answer questions. Any questions? Any questions? There's a couple you left.
I have a question. It's not regarding the probability or the project, just a general question.
Mm-hmm.
For our assignments, do you accept like late assignments, or is there a ding on it?
Late assignments aren't accepted.
Okay.
Yeah. So if you do need an extension, you have to ask by Friday. After that, it's over. I just say no. So you have to have it submitted by Sunday.
Okay.
Yeah.
Okay.
So that's really important.
Okay.
But you could do them after you don't get points up.
Okay, so we can still go in and look over it and like redo questions?
Exactly. You can redo questions and you can do that. That's good, especially before the test, which isn't for a little while, but it's a good way to study before the test.
Okay. Okay, awesome.
Yeah, but you don't get extra points up for doing that.
Right. Okay. Okay, thank you.
Okay, anything else?
Nope, that's it.
All right, well then have a great night.
Yeah, you too. Thank
And
you.
for all those who are watching this as a YouTube archive video, thanks for watching. And I'm here for you if you post on the Q&A forum for general questions or the Project One discussion forum for any questions about Project One. So have a great one.